Welcome to Math 2210, Worked Problems from Chapter 5. In this video, we'll be looking at the ins and outs of the uniform distribution. So here's a question. We're going to actually stay with this initial statement, which is suppose that the time a student takes to complete the statistics midterm exam is uniformly distributed between 75 and 100 minutes. As I said, we're gonna stick with this statement here, and we're gonna do a whole bunch of questions related to this. Okay, first question is, let's just draw a picture of the probability density function, abbreviated PDF. So the way this will look, we'll have our horizontal axis, our vertical axis. The vertical axis will be f of x, here x. So first off, uniform distribution always takes on a rectangular shape, and we're uniformly distributed between 75 minutes and 100 minutes. So a uniform distribution essentially means that f of x will just be a horizontal line going from 75 to 100. Now technically it looks like that, but usually what we do is we drop down a left and a right hand border just to give it the appearance of a rectangle. Now we have this partially drawn. The thing to keep in mind is that the area inside this rectangle must equal 1. Probabilities will be given by areas, and of course our total probabilities always have to equal 1. So first off, keep in mind that the area of a rectangle, for any rectangle, equals the base times the height. It could also be phrased as length times the width. So how long is the base? Well, the base down here is the distance between 75 to 100. You know, that's easy to see that would exactly equal 25. If it's not so obvious, you can get it just by subtracting the left-hand border from the right-hand border. 100 minus 25, 100 minus 75 equals 25. So our base is equal to 25. Now our total area has to equal 1. Notice that the height will always just be the reciprocal of the base. Base is 25, so the height has to be 1/25. 25 times 1 over 25 will equal 1. So what that tells us here is that f of x equals 1/25. Okay, so there we have drawn this. And now we're going to use this drawing in order to answer some questions. Part B is find the probability that a student takes more than 80 minutes on the exam. So let me quickly again sketch what we had on the previous slide. We have our rectangle from 75 to 100, where we have the height being 1/25. And so this probability that the student takes more than 80 minutes means x would be more than 80. So let's look at our illustration here. Let's just put 80 here, probably not drawn to scale. So we can bring that up by drawing a vertical line. And we want the probability where x is greater than 80. So as a shaded area, that greater than 80 would mean we're looking at all these values in here, between 80 and 100. If I had said less than 80, then I would have been shading instead that other sliver in between 75 and 80. Now to get the answer to this question, all we have to do is the base times height calculation. Now our base is no longer 25. Notice our base would be from 80 to 100. 100 minus 80 would be 20. So our base is just 20. And then our height is 1 over 25. That would be 20 over 25, which would reduce to 4/5. So once you've got it drawn, it's easy to answer questions. You're just computing the area of the region that you're interested in. So let's do a second question here, or third question, I guess. Same situation, and let's find the probability that the student takes between 50 and 90 minutes. Again, I want to do a very quick sketch here. 75 to 100, where the height is 125. We have this here. And so we want to find the correct region within this rectangle and compute its area. Now you might look at this question, you might think, hey, that's kind of a trick question though, because 50 would be over here, and 90 would actually be within the rectangle. What are we talking about then? Well, we're restricted to this green rectangle. So, saying that it has to be between 50 and 90, in fact, it'll never be as low as 50. The only region that would get shaded would be from 75 to 90. So it is a legitimate question to ask. It's just, the answer would be, hey, nothing happens between 50 and 75. It only happens between 75 and 90. So how do we get this probability? Well, it would be the probability that we are between 50 and 90. We would look at the picture, do our base times our height. So from 75 to 90, subtract, that means that our base is equal to 15. And then our height is the 1 over 25, so that's 15 over 25. You can reduce that, and the probability would be exactly 3/5. Another question. Told you we'd be doing a bunch of them. D is find the probability that a student takes more than 90 minutes given that the student takes more than 80 minutes. And I'm sure you recognize there, oh, this is one of those conditional probabilities. So it would be written like this: the probability that x is greater than 90 given that x is greater than 80. Now, one way of looking at this is it's saying, hey, we know that 75 or 76 or 77 minutes won't happen because we already know that it's at least 80. Now, conditional probabilities always affect your sample space. So let me draw this and show you the relevant reasoning that would have to occur. First, let's just draw our original probability distribution that you've seen me do several times already. It's from the originals from 75 to 100, and so the height here has to be 1/25. But now let's adapt this to the situation here. We know that the probability has to be greater than 80, so let me make a mark of 80 here. Okay, so when we're looking at this, we're conditioning. We say we're conditioning on x is greater than 80. And so what we're saying is, hey, we're not looking at that whole rectangle anymore. We're looking just at this rectangle. In other words, you could go and erase the other part of it. We're only going from 80 to 100. Now, if that's the region we're looking at, notice our height would no longer be 1 over 25. Because what's the base of this red rectangle? From 80 to 100 is 20. So the height would be the reciprocal of that, or 1/20th. So when you do a conditional probability, you're sort of rephrasing the original problem. Now that we've done that, and why don't I actually go and erase this part here so we don't, even think about it anymore. When we look back at this problem now, Now let's find out the probability that x is greater than 90. So I could mark my 90. Actually, that's not a very accurate way to draw it, is it? The 90 would actually be right in the middle of those, okay? And let's draw that here. So the probability that x is greater than 90 would be this region here. The probability of a rectangle is base times height. Well, notice the base of that shaded region would be from 90 to 100. That's 10. The height adapted by the conditional information is no longer 1/25, it's 1/20th. And so that would be 10 over 20. There it is, 1/2. Let's go ahead and this time we're just going to compute the mean and the standard deviation. These two formulas were found both in the text and in the author video. To calculate the mean, the formula for the mean is a plus b over 2. Now let me just go up at the top. The way this uniform distribution could be written is that x is uniformly distributed from 75 to 100. Well, a and b refer to the 75 and the 100. So the mean would just be 75 plus 100 over 2. Easy calculator problem. Comes out to be 87.5. In terms of units, in other words, the mean would be 87.5 minutes. Now the standard deviation formula is sigma equals the square root of b minus a squared over 12. For us, that means then that we would have 100 minus 75, that value squared, over 12. Do it on the calculator. 7.22 minutes would be the answer to that. I have one last question I'd like to do with you, and it's a percentile problem. We're going back to our original problem, not the one where we did conditioning. So we're looking back at 75 and 100 minutes, and we're going to find the 60th percentile. Okay, so we'll draw that original distribution. Sometimes it's called the rectangular distribution. Another name for the uniform distribution. Kind of obvious to see why that would be an alternate name for it. Remember the base here is from 75 to 100. That's 25. So our original height here was 1/25. So let's do the 60th percentile. Now we don't know where it occurs. It occurs somewhere between 75 and 100. Let's just let k be the value we're trying to find. It'll be some number between 75 and 100. And we want this area to be 0.60 since it's a 60th percentile. So we want that the probability that our value is less than k to equal 0.60. This one we're not finding the probability, we have the probability. So let's write out the left-hand side. In other words, this could be rephrased as base times height equals 0.60. Well, what is our base? Our base would be from 75 to k. Remember, you take the second value k and subtract the first value 75. So our base would be k minus 75. Our height would be 1/25, and that needs to equal 0.60. So we'll do a little bit of algebra here. The first thing I would do is multiply the left-hand side by 25 in order to cancel out that fraction. I'd also have to multiply the right-hand side by 25 also. By the way, this was not 0.25, that was times. Why don't I write it in parentheses to avoid any confusion there? So now we would have k minus 75, and 0.60 times 25, that equals 15. If you now add 75 to both sides, you will have k equals 15 plus 75 is 90. So the 60th percentile would be 90, or if you want to put minutes on it. In other words, the 60th percentile would be a 90-minute test time. That concludes this video. I hope that helped you out.